time to wash my hair.
Okay, let's go. Shampoo, 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 shampoo. Shampoo, 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 shampoo.
Get your shampoo, make some bubbles.
Bubbly, bubbly boo, make some bubbles.
Everybody fun time, shampoo time.
But what if there is no bubble? It is not only no fun, but also the hair cannot be cleaned. So in this project, we're going to use Six Sigma method to find out how to generate more bubble with your shampoo. That is our design phase. Let's move on to the measurement phase. To accurately measure the amount of bubble that certain shampoo generates, we first use the beaker to directly read the volume of bubbles. However, the gauge R&R percentage is too high to accept this measurement method. Then we try to use the head of the bubble in the same beaker to represent the volume, given the floor space is the same. We had 5 identical experiments and 3 operators. Each experiment will be measured twice. As you can see, the gauge R&R percentage is 8.64, and the number of distinct categories is 4, which means this measurement method is acceptable. So, after gauge R&R analysis, we decided to use head as our measurement method. Then, in the analysis stage, after determining the critical point, capital Y, and measurement method, we move on to analysis stage. We use cause and effect diagram to interpret the potential elements that influence the amount of the bubble. Firstly, the shampoo itself, that is, the chemical components of a shampoo. Secondly, the foaming method, including bubble flask, rub by hand, rub with hair, and also the percentage of shampoo and water, the temperature of solution, and the type of the solution. Lastly, external environment, like pressure, humidity, is also considered. Among all these factors, we need to select several significant ones to continue design of experiment. How? We tried pre-experiment, and the results show that stirring method does not foam well. So, instead, we decided to use injector to simulate a bubble flask as our foaming method. Considering the result and our experience comprehensively, we finally choose the number of pricing for injector, temperature of solution, and solution shampoo ratio to conduct the design of experiment analysis. Then, in the improve phase, we plan design of experiment to explore and confirm the effect of factors on the response. There were 3 factors in our experiment: the ratio of the shampoo and water, the temperature of water, and the number of pricing with an injector. Each factor was evaluated at 3 different levels. For the ratio of water and shampoo, 3 mm shampoo to 17 mm water, 6 mm shampoo to 14 mm water, 8 mm shampoo to 12 mm water respectively. 35, 40, 45 degrees centigrade for the temperature, and 2, 3, 4 times for the number of pricing with an injector. The response was priced as the head of the bubbles in the beaker. Following is our experiment video. After these experiments, we did design of experiment analysis using Minitab. This is the Pareto chart, indicating that only the two factors, the temperature and the number of pricing, are statistically significant because they exceeded the right line. And the main effect plot shows that the number of pricing is the most important factor. Then we analyzed the model after reducing the unimportant factors. Now, p-value is lower than 0.05 for all predictors in the least square space, and adjusted R-squared is equal to 89.52%, meaning that this percentage of the variation in capital Y is explained by the two factors included in the regression. The residual is normally distributed with a mean of 0 and a constant variance. In a conclusion, this is a good model. The response optimizer indicates we should set ratio at 3:17 shampoo to water, the temperature of water at 45 degrees centigrade, and the number of pricing at 4 to maximize the volume of bubble. Based on our design of experiment analysis, we conducted 25 experiments under optimal condition, which is ratio at 3:17 and 45 degrees centigrade, 4 times of press. To do the statistic process control, we use the IMR control chart, and according to the result, you can say all the data is under control, which means this combination is effective. Six Sigma indeed helps us to find out how to generate more bubbles with our shampoo. With this method, less shampoo, more bubbles, less chemical material, more hair on your head. We sincerely hope that everybody will have thick hair even in your 60s.